And so everything is loaded. Oh, that's really pretty. This is going to be a good one. Come on up and tell everyone what you're going to do, Chris. Welcome.
Thank you. So, finding my pieces here. OK, awesome. So it looks like we're up, good and running. Just want to mention that, because it's not a good presentation without a prize, we are doing a raffle. You can get a ticket right out. They're standing out there handing out tickets, and I'll do the drawing at the end. We've got an Echo Dot and a couple other things in there, because who doesn't like free stuff? So my name is Chris Brown. I'm a technical marketing manager with Nutanix, where I'm responsible for DevOps and some of the new products we're coming out with near the end of the month. So unfortunately, I can't talk about those. But what I'm going to talk to you today about, because we actually have two sessions. We've got today and we've got a keynote tomorrow. So after talking to a bunch of people in the booth and answering some questions and working with the other people at the show, we found that there's a lot of questions about, like, well, what the hell is Nutanix? I've heard Nutanix everywhere. People say Nutanix, but I have no idea what the tech is, what they actually do, and what they believe in. So this is going to be very focused on what Nutanix is and our story today. Tomorrow's keynote, me and one of my DevOps evangelists are going to be talking about is Nutanix Enterprise Cloud for DevOps. So they're not related, but they are a continuation. So let's get started. As we all know, there's a reason we're here. The cloud era is well underway. People are expecting to instantly be able to deploy their infrastructure or their workloads, that you want to be able to consume resources as you use them, not before. You don't want to pay for something that you're not using. You don't want to have to over-provision. You need one-click simplicity. You don't want to have to go through a 10-step process to do something that should have been straightforward. I was in support for 5 years before coming over to the dark side of marketing, so I know how often those 10-step processes can go wrong. And then continuous innovation. You think about it, and with a cloud, you never have to do an upgrade. You never wake up one morning and be like, oh man, I got to take down the entire cloud this weekend so I can give it a new feature. No, you just get new features all the time, this continuous innovation. So we all know that, that's why we're here. Another thing that we all know, just doing level set stuff, because otherwise I wouldn't be marketing, is that cloud native applications are a rapidly growing portion of IT spend, while traditional applications rapidly decrease. So if you look here in the middle, we're right near the beginning where we're hitting that burst, where we're all pioneers. But the traditional IT applications aren't going anywhere for a long time. They're going to continue to exist. They're going to continue to get investment. And if you think about it, we've got mainframes still running today. They did not go anywhere. People still pay lots and lots of money for mainframes. So it's not going to be an instant shift. You need to bring everything forward. Otherwise, you just create another silo, which is basically the antithesis of DevOps in many ways. So we cannot solve our problems using the same thinking that we used to create them. I love this quote, because we need a new approach to infrastructure that solves not only the problems that we had with traditional applications, but also prepares it for cloud-native applications. A single infrastructure that brings everybody forward and that allows you to move forward without looking back. Ha, worked in the title. So you may have seen this slide, or this ad. We took it out in the Wall Street Journal last year. You need VMware, you want AWS, you love Nutanix. I don't think anyone can argue that in the last 10 years, VMware has been the #1 disruptor in how IT and how operations do business and how data centers worked. In a good way, a very, very good way. It solved a ton of problems that we had with bare metal. I know that I forgot how much of a nightmare it is to manage bare metal servers until I had to recently. But at the same time, this brought in new issues, new problems, and new challenges. And cloud-native applications look to solve some of those. And the AWS looks to solve some of those. And the public clouds look to solve some of those. Because we need a new approach. And the problem is that some of those are too forward-looking, or they assume future competency. Whereas our goal with Nutanix is to bring both forward, allow you to give one infrastructure for both. So let's dive into how we do that. As I said, we need a new approach to infrastructure. So on the left here, we've got a pretty traditional application. We've got are applications, virtualization layer, servers, storage controllers, SAN switches, the whole 9 yards. What Nutanix did, and our first major phase of us, was hyperconvergence. At this point, everyone's probably heard that term, and you're like, oh, God, he's defining hyperconvergence again. I've heard this 1,000 times. But if you haven't, we take the compute and storage and put it down in a single box. And then we add a bunch of software-defined storage, or software features on top of that allow us to scale that out in a linear fashion, which means that you no longer have to do forklift upgrades. You don't have to rip out something just to get a slightly more capacity. You can grow naturally and organically, just like you do with a cloud. And then on top of that runs the virtualization layer. Nutanix supports 4 hypervisors today. We support ESXi, Hyper-V, Zen Server, and a KVM-based hypervisor that we released called the AHV. We'll talk about that a little bit more. And with that, we integrate all of these pieces into a single management stack, into a single plane, and in a single management point, making it much nicer. And we'll talk about what the advantages of that are in a moment as well. So I have this slide up because I really like how it shows that it's more than just hyperconverged. Sure, we can combine compute and storage together in a single box. That's hyperconverged. That was where we started. That was what we sold in 2011. Since then, we've moved up into and moving towards what we call, or we are considering the enterprise cloud, where if you look in the middle, we've got the multi-hypervisor support, we've got our own virtualization, we've got some basic hybrid cloud services, and so and so on. And adding in, most importantly, adding in things like file and block services so you get all of the features you need on a single platform. The enterprise cloud is the next step. It's bringing those cloud-native applications into the fold. So if you look at the left half here, this is bringing traditional applications up and giving them the flexibility of public clouds. And all the way on the right here, it's taking those cloud-native ideals and cloud-native fundamentals and giving them the operational pieces that come from traditional architectures that sometimes are referred to as the production cliff: security, compliance, backups, what have you. Not really backups, you don't need. Anyway. And so some of those most important pieces are container support. We've got native built into our platform. If you saw Dennis's presentation yesterday, he talked about that some, and we also have a demo in our booth, but I'll talk about that. I'll mention a couple pieces on that later on. So put another way, or to put a much simpler graphic, you've got your public clouds, which are easy, flexible, and have perceived low cost. It says 50 cents an hour, it's pretty straightforward. On the other hand, you've got your private cloud, which is on-prem. You've got full control over your SLAs. You've got full control over the compliance and the data. And you've got security. The Nutanix Enterprise Cloud Platform aims to take both of those and give you a single platform that gives you the flexibility of both, so that you're able to, once again, it's that merging of the two sides. One platform to raise everybody up. So what is infrastructure delivered as an enterprise cloud? What does that mean? First is that it means that it's agile. You don't spend hours going through installation screens and installing software and then downloading some drivers and then putting another piece in there and then realizing, oh crap, I downloaded the Windows 10 driver and I'm running Windows 8. It all happens automatically. We have a tool that will image the cluster with whatever you'd like, and as you grow the cluster, it'll continue to image the cluster with your hypervisor. So it happens in hours. And that's not just idle marketing speak. Once again, I was in support for 2 years at Nutanix before coming over, and 3 years somewhere else before that. And it did actually take an hour or two to get the process going, which was kind of mind-blowing. We want it simple. If you've got to go to training and you've got to go to learn a whole bunch of new terms and get some expert-level certifications, you haven't democratized any knowledge. You haven't made it easy for anyone to share in what you're doing. You've just made another silo. And that's not good. So we make it really simple, and we work really hard on making it as easy as possible. It's interesting because our UI and UX team has as much say in the product as the core infrastructure team, as the guys writing the storage. So we really do take that seriously. We want it to be secure. We want to be able to maintain compliance and maintain security levels without any extra overhead. And we've got some really cool technologies around that. Finally, scale out. This is probably the core. If you ever saw any of Nutanix's stuff about 2 years ago, we talked constantly about being web scale architectures. And really this means that this is the scale out architectures. This is building on the same technologies that all of the hyperscale data centers use, the Googles, the Facebooks, the Amazons. And being able to, rather than having to scale up machines and continue making monoliths, you're able to grow your cluster horizontally, naturally. So that's Nutanix. So what is the actual technology behind that? Because I've just said a whole lot of marketing terms. Well, I'm going to say a couple more and then we'll dive into it. First is that we have the base of our platform is called Nutanix Acropolis. This is the storage platform, the hypervisor platform, and the app mobility platform. And then on top of that, we run our management stack called Prism. Now, I say on top of that, they're combined together. You don't have to install extra VMs to get Prism. It's all integrated, which is nice. And the idea of Prism is that it gives you the tools that you need to manage without having to go through extra installation, without having to go through extreme configuration and all those. And some of the key features there are things like the capacity planning, which is really cool, makes some very pretty charts, and monitoring and management. So this kind of breaks down a little bit of what the main technologies in each, or the main tent poles in each are. So in Prism, as I said, we've got the infrastructure and VM management, and operational insights and capacity planning. In Acropolis, we have the app mobility fabric, the distributed storage fabric, and AHV, which is our own hypervisor based off KVM. So let's just talk about each one of those individually. How does our storage system work? How do we do the storage layout? So with Nutanix, you have x86 servers. We sell it in an appliance model just because we don't want to have a bad experience. But we also support, we have OEM relationships with Dell EMC and Lenovo. And we have software only that runs on Cisco, Klaus, Crystal servers, and I'm sure, and actually IBM. We just announced that we'll be releasing something with IBM on Power and come the summer. So this isn't just an x86 platform anymore, so I got to update my slide. On each one of the nodes runs your hypervisor, once again, one of those 4. And we run our controller VM on each one of the nodes. The controller VM takes the local disks that on the server, talks to the other controller VMs in the cluster, and pools all those resources together. It then presents that storage back down to the hypervisor based on whatever hypervisor it is. And so the hypervisor doesn't have any idea that it's actually running on local disks. Like for example, in ESXi, the CVMs pool the resources together and then present it back down to ESXi as an NFS data store. Because we can't break any of the rules of ESXi. We can't do anything special. So we follow the rules. We show up as an NFS store. The CVMs then provide all of the advanced features you expect from a storage array. Snapshotting, cloning, tiering, compression, erasure coding, whatever. Without having to do complex configuration or RAID group configuration or LUN masking or any of those pieces. So raises the question of, what does actual I/O look like on this system? The question that came up yesterday is I want to actually understand technically, like how does I/O flow? What makes you special? So we can see here we've got a node running a guest VM. It can be any hypervisor. I'm sorry, any OS. We've got a controller VM, which is our software, the hypervisor, and then the storage underneath it. The guest VM says it's time to do a write. We send it through the hypervisor, hits the controller VM, and gets down to the local storage. We're not done yet, because this isn't resilient. This isn't built for failure. This is one copy. So the controller VM then also distributes replicas to other nodes in the cluster, and we've spread this out equally throughout the other nodes on about I believe a 1 meg chunk basis. Once the write has been confirmed in 2 places, only then to return back up to the guest OS and say, good job, we're done. Now you'll notice something else here, is that we kept one copy of it local to the host. We didn't have to spread this out throughout the cluster or just spray and pray. We intelligently decided to keep a copy local. This is because when we're doing reads, we're now able to read directly from the local SSD rather than having to go over any network. This is incredibly powerful. Obviously today we've got SSDs and HDDs are the main ones. But if you look, NVMe is coming very quickly, and 3D XPoint is coming quickly as well, depending on who you ask. And NVMe can saturate a 40 gig NIC on its own, which means that unless you got 40 gig NICs throughout your entire network and probably higher, you're screwed. And then 3D XPoint, not screwed, sorry, that's a poor phrasing. You're bottlenecked. And then 3D XPoint can more than saturate a 100 gig NIC by itself, which means that if you put a 3D XPoint drive behind a 100 gig NIC, you're already hamstringing the thing you bought. You're already hamstringing the hardware. This brings us in a very interesting place that we've never been before. For the first time in history, the disks are not the bottleneck. The network is. And this is why we believe in data locality as such a critical feature of our platform. The other thing we do, is we keep this all hidden in the backseat, so you don't have to worry about it, you don't have to set it up or any of that, but it's really good to have, know that it's there, is intelligent tiering. We automatically, in our hybrid systems, we have SSDs and HDDs, so we automatically take the coldest data and move it down to SSD. Like, oh, that's pretty boring. And I agree, because all flash nodes are also very popular, which gets rid of all this, because it's all flash. At this point, flash costs have come down so much that we're seeing more and more customers just choose all flash. So why does this matter? Well, you'll always have a cheap, expensive storage. I'm sorry, a cheap, expensive storage. A cheap, slow storage, and an expensive, fast storage. It doesn't matter if that's SSD and HDD, NVMe and SSD, 3D XPoint and NVMe. You'll always have 2 tiers of storage. So this tiering will come back into play again, even if it isn't there when you buy all flash today. Covered most of the data locality pieces here. One thing to note is that our ILM will automatically move the data, especially as you do like live migrations or whatever. I'm talking a lot about VMs at a DevOps conference. That seems like a waste, but hey, tomorrow's about all the DevOps, right? So data follows, we handle all that in the back end. That's the main point here. The other thing that we wanted to bring to on-prem infrastructure is the continuous innovation. It's the ability to log in one day and have new features without having to plan downtime, without having to plan a window, without having to go down. So with our one-click upgrades, the CVMs will download the software and then say, hey, we're ready for an upgrade when you are. You can go into the upgrade and click, OK, upgrade now. We will then do a upgrade across the cluster, so a parallel upgrade, stage all the software, and then we will go through and reboot one by one, making sure the cluster gets back into a fully resilient state each time. The thing to note about this is that the VMs don't have to move, the VMs don't have to go down, the VMs don't even notice that their storage is upgrading, because the CVM can reboot without affecting the virtual machines due to our auto pathing, which we'll talk about in a moment. So this takes about 5 minutes per node, because we do have to wait for a VM for a reboot. But it doesn't require babysitting. It is actually something you can click and go. We have, sometimes you might have seen, if you've seen older presentations, is somebody doing an upgrade while cooking dinner or from an iPhone or whatever. It's really what it comes down to, is that we want to be able to confidently click upgrade. Before I came to Nutanix, I was at another large company that working on a server product that had a convoluted, let's say, upgrade process. I was never confident, up until the day I left, I was never confident in that upgrade actually working every time I clicked the button, which is not a good feeling to have for your infrastructure. These things are expensive. I get pissed if my iPhone doesn't upgrade right, and I can't expect the same thing out of a tens of thousands or hundreds of thousands dollar server that I bought. So we spent a lot of time trying to fix that and trying to resolve that. So I mentioned auto pathing. What this is one of our HA technology, one of the things we do for HA, one of our features there to make sure that the cluster is always available. If the controller VM goes down, the other controller VMs notice this and automatically enter a route into the hypervisor to give it a new access to storage. Our controller VMs are built off of, we use a lot of open source projects in R that we've customized and modified and made our own. We use Zookeeper for this. We use Zookeeper on our nodes in the cluster. We have, and by default, 3 copies of Zookeeper running. When those sessions time out, that's how we detect. That's how we know that something's wrong. We also use it to maintain state configuration and a bunch of other stuff, but that's the main piece here. When the CVM comes back up, we will automatically redirect storage back to the local CVM once it's ready for the load. This is how we're able to do those upgrades, because when this happens, when the upgrade happens, we're able to gracefully fail it over. The VMs don't even notice it going down. They do notice a small little bump in latency because now you're going over the network, which is our worst case rather than our best case. Wow, I didn't put that animation in, but I want to find more about that. So this brings up an important point. Design for failure. I mean, we're all here at a DevOps conference. We all know this. We all know that, that everything fails, that there will be failures, that you can't architect failures of hardware out. You can architect the impact out, but you can't architect the actual hardware failures. And the typical failure in the first year for a new cluster at Google is 1 PDU, 20 racks, 1,000 machines, and thousands of disks, which is a lot of hardware that you've got to be able to handle failure around. If you went into your data center today and chose 1,000 disks to fail, how much data would you lose? Google didn't lose any. They planned for failure. I mean, probably different scale. I don't know how big your data center is, but So you've got to plan for failure in the architecture, but you should also have an infrastructure that plans for failure. Because if the infrastructure plans for failure and the application plans for failure, your resiliency is even, you're even more covered. You're even more resilient. So we took these learnings that Google did. Actually, our first product was based off the Google file system. Some of the lead engineers came over and helped build that here, founded Nutanix. So we built from the ground up planning for failure, making it so that it's not an emergency, making it so it's just another piece. If 1,000 disks are failing, or even 500, whatever number you want to call it, you think that Google's running around their data center ripping out bad drives and throwing in new ones as soon as they fail? No. Once a week, they go around with a shopping cart. No, there you go, new one in. We want to give that same experience to everybody. And actually, one of our largest customers, who has about 1,800 nodes, that's what they do. Once a week, and when I was in support, it was like clockwork. Once a week, they'd call in on Monday and say, hey, I need 5 new drives, or I need 3 new drives this week. Ship them out, and that was it. He just waited, and once a week, just replaced any of the drives that failed. And that's what you get when your infrastructure is architected for failure. The infrastructure was fully resilient that entire time once the rebuild happened. And so there was no need to rush out and make it an emergency. There was no degraded RAID. There was none of that crap. So I wanted to show a technical animation here showing how we handle disk failure. So we do RF2. We do 2 copies of it. We can have technologies or whatever to reduce that. So if a disk fails, we mark the copy as live and redirect any request to that, and we make a copy. Because remember how I said that we spread replica copies out throughout the cluster, and we do that pretty evenly. We don't have like 2 mirrored nodes or hotspots in the cluster. We spread that data out incredibly well. This means that the larger your cluster gets, the faster rebuilds happen. For example, in a 64-node cluster with 6 terabyte disks, we can rebuild a 6 terabyte failed disk in 18 minutes. This is just because we're able to take advantage of the distributed nature of the system. So we're able to keep, and as you grow bigger, the rebuild time continues to come down because we've got more disks, more nodes, more controllers, more compute participating. So just real quick, I wanted to touch upon AHV. I mentioned before that it's one of the hypervisors we support. It's the one we made. It's based off KVM. We had to change the name because we changed too much of it and we weren't allowed to call it KVM anymore, or CentOS. We put our own splash. But it is based on KVM. The idea is that we looked at what the virtualization software was today, and none of it was built for the cloud or for cloud native applications or looking forward. It's all built on legacy. It's all built for storage arrays and for fiber channel and iSCSI and all these pieces. Well, we use iSCSI too, so that's a bad example. But it's built for legacy. It's carrying forward all of these modules, all of these things, all of these software that you don't care about or need. So we decided, okay, let's take a look at what is needed for a true cloud operating, so a true cloud hypervisor. And added that to AHV, paired out the rest. This means that not only is it backed up by our security stack, which is the next slide, but it's also got a smaller attack surface by default, and it's built into the system. Because it's our hypervisor, we can do some really tight integrations and do some cool things with failovers. But that doesn't mean that we're going to do AHV over others. It just means, we're still committed to making sure ESXi is still our number one hypervisor that our customers use. AHV, since we introduced it 2 years ago and really released it about a year ago, or I guess, no, 2 years ago, has been growing to last quarter, looking at the last year, 22% of our customers, or of our clusters and nodes were running AHV. And that number just continues to grow. But it's not instant, so we're not putting features only in AHV just because. We want to be hypervisor agnostic. So one of the things that I mentioned before and that we've spent a lot of time working on is our security first design and our security story. Because it doesn't matter how fast your infrastructure is if it gets, well, I mean, it does, but it doesn't matter if you get hacked. You look at what's happening in the news, you see these massive breaches every week, every month, every year. I regularly check, haveibeenpwned.com, and which you put in your email address, and it tells you which breaches your email address was part of. And that keeps growing. Data breaches are constant. I mean, it's only email addresses there, but security is critical. And it's one of the things that can get missed or get overlooked or forgotten when you're moving to some cloud native applications or trying to move forward. Because, I mean, I'm going to be honest, I don't manage a lab. One of the first things I do when I'm trying to get System Center installed is I disable the firewall on the SQL server because that damn thing won't connect. It's not a very good security story, but it's, everyone, there's this, we all see, many people see security as a bottleneck rather than something that protects the business. So our goal is to make it integrated, simple, and straightforward, and secure from the ground up. So one of the ways we get there is with automated validation and self-healing. So if you look at a traditional hardening process, you've got to install, go through the hardening guides, document the baseline, and then certify it. So that can take months. Some of these guides are hundreds of pages or really long. And the other thing is this doesn't verify if somebody goes in and turns off the firewall later. It just verifies that when it left the security desk, it was secure. What we did in Nutanix is we use a salt stack to apply a STIG, a security baseline, and then not only apply it, but also monitor for when the configuration deviates from that baseline and automatically reapply it, making security an integrated process here. So we carry this through to everything. And it does actually, I don't do a good job of telling it, but if you ever have a chance to see Simon talk about it, your mind will be freaking blown. I know mine is every time I hear him talk. But he's our security head. So we do strongly believe that security is a key component of this. But we want it to be easy to use, straightforward, and not a agility killer, and not a time waster. So that's the core pieces of Acropolis. From there, the other piece is Prism. And with Prism, our first step was we looked at what all the different management portals and all the different pieces you have today. We're like, how can we simplify this? How can we make this actually something that you look forward to logging into? UCS Manager, for example, is not something I ever look to log into because I probably don't have Java 6 anymore. So I've got to go find an old, you find the right version of Java, make sure it's updates, and go through all these pieces, and nightmare. So we take all those pieces and we decide to move it down, or not decided, we spent a lot of time engineering it into HTML5 down to this interface here. Now, that's great, but what does it let me do? Simplicity and usability is one piece, which is important because, once again, you don't want to create new human silos or new skill silos with complex infrastructure. One of the big things that we've released in the last year for this is capacity planning. And, well, actually, I guess, so this, yeah, sorry, I apologize. I'm getting a little ahead of myself there. Saw this picture, and it's the same one we use for capacity planning. So we'll talk about that in a moment. What are the pieces that are in Prism? Now, one thing to note about Prism is that it doesn't call any private APIs. So anything that you see here or anything that you can do in Prism, you can take the same API calls and make it your own. You can automate it. You can do whatever you want with it. We also have a bunch of other automation tools, which we'll get into a little bit more tomorrow when we're talking about some of this journey. First piece is the full stack management. That's where we started. In our most recent release, we've added self-service, both for infrastructure, regular VMs, and also for containers. And if you want to see a demo of that, make sure to come by our booth. We're actually right there, so it's not that far. But this is the idea is that you're able to not only give, your users are able to consume VMs and containers the same way. They don't have to learn a new interface, or it depends on, you're able to deliver containers, which is really cool, in a persistent way as well. So from there, we build up to personalized insights. Being able to search, say I want to find VMs that have 100% CPU utilization or greater than 80% over the last 30 days. You can also customize it because what you care about is probably different from what your workers or your managers care about. And then finally, we added predictive analysis. And this is the runway planning and recommendations and just-in-time forecast. One thing that I want to emphasize about these is that it's not extra products to install. It's not months of configuration. It's literally click, enable, and that's it. It's not, and then the system will automatically start learning, and it'll start giving you insights. You don't have to install a DB and connect back to the DB, and no, that's not simple. That's not what we're about. So with Prism Central and with Prism, you're able to get end-to-end cluster management, be able to deploy the cluster, image the cluster, manage the cluster, upgrade the cluster, expand the cluster, image the new nodes, add them in, and of course, most importantly, or not most importantly, but very critical, is shrink. If you have only a scale out or a scale up, and you're not able to condense and move resources when you need to, it's not a very flexible infrastructure. So you're able to do all of these directly from Prism. You're able to do one-click upgrades, not just for the Nutanix software, but also for hardware, firmware, and the Hypervisor itself as well. This is the capacity runway I was talking about. I got ahead of myself. So we're able to, we take a look at your system. We see what your workloads are. We see what your VMs are actually doing, not what you've configured, not just how much RAM they've been configured, but we gather actual performance metrics. And for clusters, for nodes, and for containers, which are, it's kind of poor terminology, but we named our data stores containers about 7 years ago. And that's really come back to bite us, because now we have no idea which container we're talking about. But so these are storage containers, not compute containers. We're able to examine dead resources, find resources that are over-provisioned. We're able to say things like, hey, you assigned this thing 16 gigs of RAM, but it's never used more than 4. You probably can recover some there. It's show you dead VMs, VMs that haven't been turned on in over 30 days, and basically showing you ways to eke the most out of the infrastructure you have already. And if that's not enough, you can also specify, what your target runway is, how many days you want your infrastructure to be good for. And we will then use the algorithms we put into our sizer, which is our planning tool, and it will tell you what kind of nodes you need to add and how many in order to get to that desired runway. And this is what it looks like. You saw it already. We are able to, as you can see there, we're able to tell the difference between a constant general growth and then a one-time load. We're able to give you CPU, memory, and storage usage, how many days that is, and you can click on the view recommendations to figure out ways to grow it out and extend it out further. Really, this is about eliminating guesswork. You no longer have, the idea is that we don't want you to have to sit there and be like, well, I think, 1,000 CPUs, maybe if we do 400, maybe 10 nodes. No, we want to get rid of all that crap. We want to make it so that you get the infrastructure you need when you need it without question, without worry, and with confidence. And as part of that, we also have what we call just-in-time forecast. This is the ability for you to take either a generic workload from our sizer or a workload that you've got running on your system already. If you take a workload that's running on your system already and say, hey, I want to clone that 100 times. I'm going to put another 1,000 copies of that up. Prism Central Prism will use the information that it knows about that VM, its growth patterns, its utilization, and predict out what that's going to do to your infrastructure. And it'll give you a view of what your infrastructure is going to look like once that workload's on there. Because this is powered by Sizer and powered by the machine intelligence it's getting from your data, it's constantly improving and trying to give you the best answer, most accurate answer that it can. Nutanix doesn't just say, we don't just say that you should, merge clouds, but we also we abide by a cloud pace in many ways. We're not quite to the instant releases, but we do powerful, impactful releases on a very regular basis. So if you look here, this is kind of a reverse roadmap. Going back to the product launch in 2011. So in 2.5 was 2.5, 2.6 was really our first public GA. We launched it. We had some internal or some smaller users, and then 2.5 came out in 2012. 3.0, which added backups and DR natively in the platform, along with the non-disruptive upgrades, because we didn't actually have that in the first version. And compression was released later that year. 2013, we added Hyper-V and Prism, because that was actually where Prism came in. Before then, it was an interesting GUI. And deduplication. And I'm not going to read through this whole thing because that's pretty boring, but the idea is that we're constantly, as you can see, we had 3 major releases in 2016 alone. 4.6, for some workloads, quadrupled performance. We enabled hypervisor conversion and the XFIT predictive analysis in the beginning of the year. In the middle of the year, we added block services and, most importantly for us here, container support. And then finally, we added file services, self-service portal, what-if analysis, and dynamic scheduling at the end of the year. We're going to continue this pace, and we're actually going to increase it in some ways. But if you want to learn more about that, make sure to come check out .next, which is our conference at the end of the month, because we've got some really cool stuff we're going to be announcing around that. So I'm down to my last 7 minutes here, so go through these last couple of slides pretty quickly. I mentioned a couple times we have container support. And what that means is that we can now natively not only serve containers to end users, but also manage the data for containers right from Prism. I went too many. Developers, if you're using Docker, you can install the Nutanix Docker volume plugin, or the Docker Nutanix volume plugin, depending on which way. And continue using your existing workflows. Except when you specify volume, just tell it it's a Nutanix volume. So create the volume, and then the administrator can manage that data, independent of where that container is running. Then the Nutanix Docker volume plugin will handle the automatic mounting of where it's needed, and move it around, and do all this other crazy stuff. The idea here is that you are able to get the agility and flexibility developers need, along with the control that the operations team needs. And this is only a beginning. We're taking this even further. So the self-service portal, it's pretty straightforward. Everyone knows what a self-service portal is. You've got different groups. They put in requests to IT, and then instead of having to go to IT, they go to a portal, and they automatically get their resources. Yeah. The thing here that I wanted to emphasize, and the reason I put these slides in, because I have no idea how many times you guys have probably heard self-service portal defined, but it's more than, I don't want to add another one to it. But the real thing here is that containers can be done through the self-service portal as well. And you're able to search Docker Hub, download or your local repository, deploy Docker images, connect them to networks, give them storage, mask them to networks, move them around, do all these different things to them directly from self-service portal, giving you a single place to get both virtual machines and containers all in one. So what this finally comes down to, and what this means, is that we have a single platform here that we've designed to be good for every workload. That's what this entire thing building up to, that's what it all means. That's what we're all, main message. We started with VDI 5 years ago. If you asked us what our #1 workload was, we'd tell you VDI. We're no longer that company. VDI is now a minority of the workloads running on us. And I believe it's 90% of our customers run 2 or more workloads on us. And many times what happens is you'll try it for one workload or a test workload, and then end up expanding that to others. We've got solutions for your choice of hypervisor, for Hyper-V, for VMware, for AHV, for Docker, and for OpenStack. We've got solutions for all of your traditional applications and containerized applications now as well. So on that note, I wanted to just do a quick description of what one of our customers is doing today and how they have adapted using the Nutanix infrastructure to their workflow. So this customer has a set of IoT devices that are medical devices. These guys are feeding data into the cloud, which is Azure in this case. They've got 5 microservices that are running there to do processing. They also have AWS that they use for dev. So they develop the microservice in AWS, move it over to Azure for production. Once Azure's processed it, they send it down to Nutanix. And Nutanix hosts the Oracle DB. Because of the security, isolation, control, and power that it gives it, they're able to they keep the Oracle on-prem, and they put it on Nutanix to not lose those cloud benefits they've come to know and love from the microservices up above. And finally, they took all of the old gear that they replaced and put it into an OpenStack cloud for burst capacity, just as an extra thing because they still had life in that hardware. So, this isn't to say that, so this is really an example, as you all know, as I'm sure you've all developed, you've all seen. Multiple clouds are in use, multiple infrastructures, multiple pieces, multiple technologies. There's some really cool things we're working on that makes this even easier, but unfortunately, that's one of the things I can't talk about. So make sure, if you're interested in learning more about that, if you're interested in learning more about what we do, what our customers are doing, and how we're approaching this, make sure to stop by our booth. And then, of course, tomorrow, I'll be back up here with Mark Lave to talk more about the DevOps side of things, the journey, and how we can move along the path and how we can move to a better future. So with that, I've got the raffle. I wish I had the Price is Right music. So the winning ticket is 638213. Everyone get your tickets ready? See how you got it? Awesome. We got a winner. Thank you. Well, thank you all for coming.
Thank you, my friend. Now you can keep that.